Hello everybody. In the last lecture, we have discussed duality property, right? In the duality property, we have discussed self-dual expression up to that. I have not proved what is the number of self-dual expressions proof. Okay, 2 power n minus 1. That proof we'll discuss after discussing min terms, max terms, SOP, PYQs. Now, one more thing in the duality property we left is negative logic, positive logic. If you can refer your notes. I have given the point after the duality property. What is the point I have given? Duality property is used to convert a positive logic system into negative logic, or a negative logic system into positive logic, and vice versa. Okay, let us use that point. Okay, first, what is positive logic? What is negative logic? Let us understand. What is positive logic? What is negative logic? Let us understand. First, write down. I will explain. Write down. Out of the two logic levels available, if logic 1 is assigned with more positive, logic 1 is assigned with more positive, then it is positive logic. Otherwise it is negative logic. Listen here. Suppose you have logic 0, logic 1. Say in the computer or in the processor, how you represent your 0 and 1 with two different voltage levels. Say 0 volts, 5 volts, 2 volts, 3 volts, any two. Okay, most general we can come across for TTL is 0 volts and 5 volts. TTL IC family 0 volts and 5 volts. Okay, so logic 0 is assigned with 0 volts. We treat voltage 0 as logic 0, voltage 5 as logic 1. Okay, suppose if you do reverse, if you do like this, what we call it as positive logic. If you do reverse, 5 volts with 0 volts, that is, out of 0 and 5, which one is more positive? 5 is positive. If 5 is assigned to 1, positive logic. If 5 is assigned to 0, that is, we have used reversely. 0 is assigned to 1, then it is negative logic. Now, using this, for example, you have minus 2 volts, minus 3 volts. Whether it is positive logic or negative logic, you can tell me. See, what is the standard definition? Out of the two available, which one is more positive? That is given for 0 or 1, you should check. See, in this family, these two are the logic family, voltage levels, minus 2, minus 3. Which one is more positive? Yeah, minus 2. So, minus 2 is given to 0. So, more positive is assigned to 0. It is positive logic. If you do reverse, more positive is assigned with 1, negative logic. Please understand simply, 0 is assigned with 1 voltage levels. 1 is assigned with 1 voltage level, like you are pressing buttons on, off. Okay. So, a particular voltage comes, we treat it as 1. A particular voltage comes, we treat it as 0. In that two voltages, more positive given for logic 1, then it is positive logic. More negative is given for logic 1, negative logic. Okay. Now, one of the application of your duality property is to convert a positive logic system into negative logic, or a negative logic system into positive logic. For example, see here. You have an AND gate, AND operation. Zero, zero, 0, 1, 1, 0, 1, 1. What is the output of AND operation? 0, 0 and 1. Right. Now, take OR operation. Otherwise, one second, please. This is my AND operation. Apply duality property. What is duality property? Every 0 is replaced with 1. Every 1 is replaced with 0. Not only in the output, at input also. Please, very important point. Understand difference between inversion and duality. What is inversion? Already we have discussed. Inversion means output is complemented. Complemented means in the output 0 replaced with 1. 1 replaced with 0. Input is not touched. That is inversion. In the duality, what is duality? All zeros, whether it is input or output, all zeros are replaced with 1. All ones are replaced with 0. So here, let me do that and check what will be the output I will get. Apply duality property. So here you observe, all zeros you replace with 1, all ones you replace with 0. Now you observe, here 0, 0 is giving me 0. All other cases, what is the output I am getting? 1. What is this operation? Which gate it is? 0, 0 is 0, whether it is 0, 1 or 1, 0 or 1, 1. All cases, what is the output? 1. What is this case? Right, OR gate. So it is proved or not? AND gate, duality property, OR gate. Okay. Similarly, if you have in the positive logic system, AND gate. In the negative logic system, how it will work? OR gate. Please understand the meaning, concept properly. See, you have designed a particular logic gate in a positive logic system. Okay. But you are using it in a negative logic system. Then what happens? All ones will become zeros, all zeros will become ones, which is nothing but your duality property. So you can say like this, if you design a AND gate in a positive logic system, it will become OR gate in the negative logic system. That is the relation given by duality property. Is it clear? Duality property will convert a positive logic system into negative logic system. Okay, say any complex function, how to find, you have designed it in a positive logic system, you are using in negative or reverse. Then how to find the original answer is by using duality property. Okay, copy it. Okay, copied. Right. Now, let us continue with the remaining part. That is about your duality property. Okay. Now, the next one after the duality property, keep the heading De Morgan's law. De Morgan's law. You can copy it, I'll explain. De Morgan's law. This is what we call it as De Morgan's law. See here. In the De Morgan's law, what is ABC whole bar? ABC whole bar is nothing but ABC whole bar is nothing but A bar into B bar into C bar. Please understand. ABC का product whole bar is equal to sum of individual bars. A bar plus B bar plus C bar. Similarly, A plus B plus C whole bar is equal to A bar into B bar into C bar. A plus B plus C का whole bar is equal to product of individual bars. Okay. See here, you may have the doubt with the proof. You can prove it with the help of truth table very easily. Taking all zeros to all ones, check the result of two cases, you will get the same. Another way is with the help of Shannon's law. I will give you. See here. Next, keep the side heading. Shannon's law. Shannon's law. Write down. Shannon's law. According to Shannon's law, the complement of any logical expression can be obtained by finding its one-time dual and complementing each individual variable. Right. Write down procedure. First point. Write down this. Interchange plus with, write down the first point like this. Interchange plus with, directly write down this symbol sufficient. Interchange plus with dot, dot with plus, nothing but end with or with end. Second point, 1 with 0, 0 with 1. Third point, complement, please copy, complement each individual variable. This is what we call it as Shannon's law. What is Shannon's law? We can find complement of any function by finding its dual first. That is this part, finding its dual first and complementing each individual variable. Simply like this. If you have a function f, you can have any number of inputs, A, B, C and so on. Okay. And here you got the transformation and you got the function f. Okay. How to get complement of this function? Complement of this function is equal to taking inverter at the output. Okay. This is called f bar. F bar can also be obtained by another way. What is that another way to obtain the f bar? Take all the inputs complement. In place of f, find f dual. This will also give you f bar. I will explain again. Please wait. Say this is my function. A, B, C are the inputs, whatever may be. This is the function which is giving me output equal to some f. Okay. Now, how to find complement of the function? Complement of the function is nothing but output complement. One method. Or another way to find the complement is take input complements and in place of f take dual. Both will give you same. Best example you can see here. See here. A, B, C are present. If you want A, B, C whole bar, what is the dual of this? A plus, what is dual of A, B, C? A plus, B plus, C and take individual bars. Proved or not? Like that you can prove this one also. Okay. For your better understanding, let us take one example. say my function f of ABC equal to, randomly I am taking a bar, b bar, a b c bar, a bar, b bar, c bar. What is f bar of ABC? This is symbol we can use for bar. Okay, total complement of the function is, how to find it? Easy way is, take dual of this function. This is Shannon's law. Take the dual of the function. What is the dual of the function? A bar plus b bar. In place of plus, you take dot. Don't touch variables, you take as it is. Okay. A plus b plus c bar into, take that as it is. A bar plus b bar plus c bar. Is it clear? A bar plus b bar into a plus b plus c bar into a bar plus b bar plus c bar. What is this? Dual of the function. Now take here individual bars. For all ABCs. Now what is the answer? A double bar. What is A double bar? A. Okay. Plus B into A bar plus B bar plus C into A plus B plus C. Or simply blindly you can say take the dual. If you have bar here, you don't get bar in the complement. If you don't have bar, you will get bar in the complement. But first we should take a dual of the original function. This is how to find complement of any function. Duality property can be used to find complement of any function. How to find complement of any function? First you need to find, take dual of the given function. After taking dual of the function, complement each individual variable. That's all. Copy it. Okay, right. Now the next one, that is about what the Boolean basic laws. What are they? Commutative property, okay, associative property, distributive property, consensus law, transposition law, duality property, Shannon's law. Okay, these are the 7 basic important properties we should remember for the Boolean algebra to solve any logical expression. These are very useful. Based on this, we can solve most of the logical expression. Okay, right. Now, let us take few examples. At the end of the chapter, when we discuss the questions completely of the chapter, we will discuss more number of questions. Just for continuity, let us take few questions on this topic, Boolean algebra. Okay, whatever we discussed, these 7 properties based on this, let us see few more, 2 or 3 questions based on this examples. Okay, write on the first question. Write down. The function f of ABC equal to, function f of ABC equal to AB plus BC plus AC. Please see. F of A, B, C equal to AB plus BC plus AC. Then what is f bar of ABC. Then f bar of ABC equal to, write down this, a bar B bar plus B bar C bar plus A bar C bar. True or false? Copy it. F of ABC equal to AB plus BC plus AC. Then F bar of A bar B bar plus B bar C bar plus A bar C bar is, what is that? Sorry, F bar of ABC equal to A bar B bar plus B bar C bar plus A bar C bar. True or false? You can tell me the answer. What is the answer you can expect? Sir, complement means you should take dual and complement each. Here you have directly complemented each variable, so you may think the answer is false. No. Answer is true. Why it is true? In the last lecture, we have discussed one important condition. What is that? Self-dual expression. What is self-dual expression? After taking dual, if you are getting the same expression back, it is a self-dual expression. I have also given example of this. What is this? What is this? Self-dual expression. So, you can understand, if you find f bar of ABC, what is the procedure? Just now we discussed A plus B into B plus C into C plus A. Take all individual bars. But this will be equal to, you can expand and check if you have doubt, A bar B bar plus B bar C bar plus C bar A bar, because it is self-dual expression. Dual and original function both are same here. So, if your function is a self-dual expression, directly take the complement of each individual variable, that is the same as total complement. Is it clear? For example, see here. No need to copy, just remember this. Suppose previously what we have done, this is what we have done. F bar is equal to input complement dual we are getting. But here no need to take dual, because F dual is equal to F, because it is a self-dual expression. Directly you complement the inputs or outputs, both will give you same. That is what we discuss as self-dual expression. No need to copy this part. Just copy that. Right. Next question. Write down. Minimize the function f of ABC equal to, minimize the function f of ABC equal to, please copy this expression. F of ABC equal to A bar BC plus AB bar C plus ABC bar plus ABC. Okay, let us try to minimize this function. Right, see here. I can take C common in first two expressions or not? A bar B plus A B bar into C plus, I can take AB common here, C bar plus C. I will explain just later when we discuss, just in the coming lecture or here, about all the logic gates, XOR gate, NAND gate, NOR gate, all the conditions. This is what we call it as XOR gate expression into C. C bar plus C is equal to 1, which is AB. Or you can take it as it is also, nothing wrong. Okay. So you observe here, after this you cannot minimize this expression further. You cannot take anything common here, or you cannot do any minimization further. That is the here, but this is not your minimized answer. Then how to do it, sir? Right. If your observation is good, better see here. In the first and second term, A, okay, A bar, B, C. Okay, here A, B bar, C. Here A, B, C bar. Here A, B, C. See the first term, last term. Can I take anything common? In the first and last, you can take B, C common. Okay, here you can take B, C common. Second and this, I can take A, C common. Third and fourth, I can take A, B common. You may have the doubt, sir, you have only one ABC, how to take common for all the three? You know, in the basics of Boolean algebra, I have given A plus A. What is the answer? A. A plus A plus A plus A plus A. Any number of times you add a particular term, you will get the same. So here, for minimization purpose, see here, same expression, let us take it. F of A, B, C equal to A bar, B, C, A, B bar, C, A, B, C bar, A, B, C. Please observe here. Here, I will add two more ABCs. Can I add it or not? You tell me. ABC plus ABC plus ABC. What is the answer? ABC plus ABC plus ABC is equal to 1. Sorry, 1 ABC. You can add any number of ABCs, you will again get ABC only in the Boolean algebra, because A plus A is equal to A in the Boolean algebra, right? Now, see here. In the first one and this, can I take anything common? BC can be taken common. A bar plus A. Similarly, the second one and this one, you can take AC common, B bar plus B. This one and this one, you can take AB common, you will get C bar plus C. Okay. Now, A bar plus A, 1, so it is BC. B bar plus B, 1, this is called AC. C bar plus C is called 1, it is called AB. So this is the minimized expression. Sir, how will you say this is minimized, that is not minimized? You will be having the doubt. See here. Here, how to check whether it is minimized, which one is minimized means, depending on number of gates, one method. Another way is count here, what we call it as literal count. Count the number of variables here. Yeah, 1, 2, 3, 4, 5, 6. Here, 1, 2, 3. So multiply with the C. 1, 2, 3, 4, 5, 6. If you take it common also, 7, 8 literals are coming. Literal count is 8. Okay. What is literal count means? Just count it. How many are there? 1, 2, 3, 4, 5, 6. Even C coming 2 times, every variable is called as one literal, whether it is complemented or not. Okay. How many times it comes? Those many times you can add it. 1, 2, 3, 4, 5, 6. Here literal count is 6. Here don't take this format, because it is again this one only. Okay. It is not minimized. So C into this 3. C into this plus 3, 6 plus 2, total 8. Okay. Anyway, when we discuss about the K-map and the problems, we'll discuss very clearly what is the literal count. Okay. Now, see here. This is the minimized answer. This function is having one important name, what we call it as 3 input majority gate. So what is this majority gate? I will come to that. What is the meaning of majority gate? It is also, one second, another way, another name for this is 2 by 3 voting logic. What is another name for this? 2 by 3 voting logic. You can see here. You can call it as a 3 input majority or 2 by 3 voting logic. What is the meaning? Say you have 3 inputs. Out of the 3 inputs, majority of inputs are 1. Okay, your inputs ABC, in that majority of inputs are 1, your output is 1. Majority of inputs are 0, your output is 0. Majority of inputs are 1, you will get 1. Majority of inputs are 0, you will get 0. What is the meaning of majority here? Out of the 3, what is the meaning of majority? Minimum 2. So out of the 3 inputs, minimum 2 inputs are 1, output is 1. Minimum 2 means all the 3 also can be 1. See here, out of the 3, if A, B is 1, A and B both are 1s, A and C both are 1s, or B and C 1s, any 2 of them or all the 3 are 1s, output will be 1. Similarly, if any 2 of them is 0 or all the 3 are zeros, output is 0. That's why it is called 3 input majority gates. Majority of the inputs are 1, output is 1. Majority of input is 0, output is 0. It is also called 2 by 3 voting logic. You may have the doubt, sir, what is the importance of this name or this logic? I will show you one practical application. Let us take some example of one industry. Some chemical industry is there. Okay. Say here in this I am storing some acid. Okay, some very concentrated acid is being stored. I have one control valve here. So I have some transducer which will detect the level and give the feedback. Whenever level reaches a particular set point, I should close this valve. Okay. So here, this is say a simple control logic. Just liquid is flowing through it, that may be acid or something. Whenever it reaches some level, I should close it. I have designed some level switch is there. That switch will take the feedback and it will give some, it will be used to open or close the valve. Okay. But if it is a critical industry, very high concentrated acid, it should not overflow. Okay. For example, whatever you have taken very good device, very best in the market, level switch and all, whatever may be, the transducers, everything is best. But every device will be having some certain age limit, or due to some environmental conditions or something, it has gone faulty. Out of the 1,000, one may go fault, but that one is with you. Okay. If it is not working, what happens? This flow comes, overflow. It may damage your whole system. So, if it is a critical application in industry, they never rely on single device. They will take the same device again and again. Okay. They will take 3 switches or 3 transducers. Okay. Whatever maybe you are having, in place of 1 reading, they will take 3 readings. And these 3 readings, they will give to this kind of majority gate. Then what is the assumption? Sir, one may be going faulty, but the remaining 2 are 1s, your output will be 1. Remaining 2 are 0, your output will be 0. Accordingly, it will on or off your valve. Okay. So, 1 may go fault also, still it will work. Okay. If 2 goes fault, we cannot do anything. But out of the 3, what is the assumption? 1 may go wrong at any time. Still, majority of the 3, out of the 3, 2 is saying 1. So, take it as 1. 2 is saying as 0, take it as 0. Assuming it can minimize the chance of fault compared to previous case. Out of the 3, one way by chance, if any one of them has gone wrong, still it will give you operation properly. Okay. They can check periodically and all those conditions will happen, but this is the where industrial application where we use this majority gate logic. Okay. No need to copy this part, just copy the solution. I hope you have copied this part. Right. Let us take one more question. Right. Write down the question. Minimize the function f of abcd equal to, minimize the function f of abcd equal to, please copy this function, f of abcd equal to this one, ab plus a bar c plus b bar c plus c bar d into, write down this, please see the board, into 4 literals, minimize the function f of abcd equal to this one into 4 literals, right. Now, before going to the question, we should know the definition of literal properly. Write down the definition. Literal is a variable. Literal is a variable in either normal. Literal is a variable in either normal or complementary form. Literal is a variable in either normal or complementary form. Right? Listen. Literal is nothing but a variable. Here, how many literals are present? A is one literal, B is one literal, A bar one literal, C one literal, B bar one literal. C already counted, na? It is not a different literal. It is the same literal only. Don't count. C bar D. Total how many literals? 7 different literals. Okay, please understand. What is literal count? If they ask literal count, we should count C 2 times comes also, we should count it. In that case, blindly 1, 2, 3, 4, 5, 6, 7, 8. 8 is the literal count. Is it clear? 8 is the literal count here. How many different literals I am having? Only 7 different literals, because 8 C is repeating. Okay. So here how many literals? 7 literals are present. We should convert into 4 literals, or we should minimize this expression into 4 literals. Let us see whether it is possible or not. Okay, is it clear? Here literals are 8. If you want literal count is equal to, literals are 7, literal count is equal to 8. That is the difference. Literals means only we don't count which if it is repeating, but literal means we don't count if it is repeating. Literal count means even if it is repeating, blindly count it. Okay. So if your expression is minimized, it should be least literal count that we calculate. Okay. Now please listen here. How many literals? Let us try according to the question. A, B. You can take C common here. A bar plus B bar plus C bar D. Now, A bar plus B bar by De Morgan's, we can write it as AB whole bar plus AB plus C bar D. So, can I write AB whole bar C? Na? I am writing for your easy understanding. A bar plus B bar is AB whole bar into C, because it is commutative. You can write in any way. Now, you see X plus X bar Y, that is AB plus C bar D. Sir, how? Distributive property. What is distributive property? A plus A bar B is equal to A plus B. What is distributive property? A plus A bar B is equal to A plus B. So here take it as some X plus X bar Y is equal to X plus Y. Now AB plus C plus C bar D, which is equal to C plus D. So you can count the number of literals. How many? 1, 2, 3, 4 literals. Okay, copy it. Okay, that is about some examples of your Boolean algebra. Let us see few more. Okay, once we complete your chapter, we'll see few more questions based on this. Okay, different levels. Now, in the chapter, the next part of Boolean algebra. Okay, before going to the next part, please understand, in the exam point of view, given a question, they ask you to solve, always first priority is given for K-map, not for Boolean algebra. Why? Because in the previous class we have seen, I have added ABC, ABC, ABC. That point you may get it or not. There is no rule that immediately you get that point. Sir, ABC plus ABC plus ABC I should add. It is difficult. Boolean algebra, sometimes you may end up with confusion, whether it is minimized or not. Okay. So that all those we can overcome with the help of K-maps. We see the next part. Okay, later. Now, before going to the K-maps, let us have some basics about your logic gates. Right. Now, keep the heading. Logic gates. Logic gates. Logic gates. Okay. In the logic gates, keep the heading before, sorry, one second. Before going to all the logic gates, just I'll give introduction. That is, what are the different logic gates we are having and all. Okay. So what are the basics of logic gates I'll give in this lecture. In the next lecture, we'll discuss what are the logic gates, what is the internal part and all. Okay. Just in this lecture, just for continuity, write down few points. Logic gates. In the logic gates, write down floating input. What is floating input? I'll tell. First, write down floating input. Floating input in TTL. What is TTL? Also, I'll explain. Just write down floating input in TTL logic family. Floating input in TTL logic family is treated as logic 1. Is treated as logic 1. Comma. Floating input in the ECL logic family, ECL logic family is logic 0. is logic 0. Next line, floating input in the CMOS, floating input in the CMOS is undefined. What is floating input? Floating input means we call it as a unused input. Say you have A, B, but this input is not used, left open to air. Okay, like this. If it is unused, not connected to ground or any voltage, then it is called as floating input. These are called logic families. We discussed in the logic families topic, or you can say simple for understanding, technology used to make your gate. Transistor logic, emitter coupled logic, or CMOS. In the transistor logic, it is 1. ECL, it is 0. In the CMOS, it is not defined. Okay, we will prove it also when we discuss about the logic family conditions. Okay, now logic family topics. Now, in the next lecture, we'll see the basic logic gates, how to use the unused inputs and all conditions in the coming lecture. Okay, we'll continue in the next lecture. Thank you.